Okay, we're going to go a little out of order here. Instead of going on to, I guess, 3.8 would be the next section according to the book order, we're going to go to 3.10 and then circle back to get those other sections, because 3.10 really does follow exactly on the heels of implicit differentiation. So 3.10, related rates. So the following are examples of related rates. A ladder 20 feet long leans against a vertical building. If the bottom of the ladder slides away from the building horizontally at a rate of 3 feet per second, how fast is the ladder sliding down the building when the top of the ladder is 8 feet from the ground? And I bolded it, but now we'll underline it in red. It talks about two rates, rate of 3 feet per second, and then how fast. Remember, fast, velocity, and what velocity really is the rate of change of position. And so we've got two rates, and they want to know, as this one thing happens, how does that affect this other thing? Related rates. Same thing on the next one. As sand leaks out of a hole in a container, it forms a conical pile whose altitude is always the same as its radius. If the height of the pile is increasing at a rate of 6 minutes per second, find the rate at which the sand is leaking out when the altitude is 10 inches. Again, it gives us one rate, then asks us how something else is changing. Related rates. We see we are given information about rates of change, then asked to find a different rate. This is how we're going to recognize related rate problems. Eventually, we're going to have two different types of word problems. How you will recognize the related rates as opposed to the problems that are come later is related rates are always going to talk about rates. Now, I can't give you an always on these guys. Each problem is slightly different, but there are some general guidelines. 1, read the problem multiple times. Really important step, reading the problem. 2, draw and label a sketch. Do not put in the sketch any quantity that is subject to change. 3, identify and label all given quantities and quantities to be determined. Make sure the variables used here match the variables in your sketch. I will be grading what you write, not what you were thinking. And so if you don't tell me what x represents, and then you say that dx dt equals 3, if you didn't tell me what x meant, you haven't told me what the value of 3 means. You've got to tell me what your variables mean by labeling appropriately. 4, write an appropriate equation relating all the quantities in the picture. 5, implicitly differentiate both sides with the equation with respect to t. T, because all of these things are going to be dynamic things that are changing with respect to time. 6, substitute in the known quantities and possibly find any missing quantities. 7, solve for the desired quantity. So there are my basic steps each time, and now we're just going to do some problems. Okay. As sand leaks out of a hole in the container, it forms a conical pile whose altitude is always the same as its radius. If the height of the pile is increasing at a rate of 6 inches per minute, find the rate at which the sand is leaking out when the altitude is 10 inches. So I've read the problem. Now I'm going to draw a picture. So step 2, drawing a picture. As sand leaks out of a hole in the container, so there's my sand leaking out of a container. It forms a conical pile whose altitude is always the same as its radius. So my best bet to try to draw this, there's my radius, there's my height, and there's a conical pile. And then it specifically says that the altitude is always the same as the radius. So I'm going to label both the altitude and the radius r. Now you don't need to verbally tell me that r equals the radius. I can pick that up from the picture. That your picture is a way of declaring your variables. So I look at the picture. From the words, I know that's supposed to be a cone. We all know that cones have radii. I've labeled the radii. Okay, so there's step 2 that says, draw and label a sketch. Do not put into the sketch any quantity that is subject to change. Notice I did not put the 10 in there. Think about the picture that as my sand drops out, that height is going to get bigger and bigger and bigger. So that 10 is a specific moment in time. The picture represents the dynamic situation, represents how it can change over time. So the 10 does not go in the picture because that height, both the height and the radius are changing. So step 3, identify and label all given quantities and quantities to be determined. Make sure the variables you use here match the variables in your sketch. So step 3, I'm going to go through the phrase by phrase and determine what each phrase tells me. As sand leaks out of a hole in the container, it forms a conical pile whose altitude is always the same as the radius. That gave me my picture. The next sentence, if the height is increasing at a rate of 6 inches per minute. Okay, what that has told me is that dr dt, r, because that's the way my height is labeled. And so height, altitude, look at my picture, labeled r. A derivative because it's a rate of change, increasing at a rate. Rates of change are derivatives. So what this phrase has told me is that dr dt is 6. The next phrase, find the rate at which sand is leaking out. So find. Now we got to decide what sand leaking out means mathematically, geometrically. Sand leaking out, find the rate at which the sand leaking out would be the same thing as saying find the rate at which this entire pile of sand is changing. That as sand leaks out, that pile, that three-dimensional pile keeps getting bigger and bigger and bigger. And they're asking me about all the sand, how fast the sand, all that sand is leaking out. That three-dimensional shape. Well, we measure three-dimensional shapes by volume. So I'm going to let V equal volume. And so this is telling me, we let V equal volume. This is telling me find dV dt. Find the rate. Rates are given by derivatives at which the sand is leaking out. So saying find dV dt. And then the last part that we need to do, that last phrase, when the altitude, that's not how you spell altitude, when the altitude is 10, when r equals 10, because I have my altitude, my height labeled r, so when r equals 10. And so there I've gone through and decided what each phrase has told me. So now step 4. Step 4 says write an appropriate equation relating all the quantities and the picture. So I need an equation. That relates a cone, volume, radius, and altitude. And if you don't like the word altitude, height. Now, all these guys are going to be basic geometric formulas, and I have posted in MyLab Math a sheet of basic geometric formulas. And one of the geometric formulas here would be volume of a cone, which is volume equals 1/3 pi r squared h. That's the volume of a cone. Now, what I expect you to have memorized for tests or quizzes I expect you to know everything about right triangles. So that would include trigonometry, the Pythagorean theorem, area, possibly perimeter, but I don't think perimeter creeps up, but everything about right triangles. So that's Pythagorean theorem, area, trigonometry. Everything about squares and rectangles. So that would be perimeter and area, and then boxes, which would be surface area and volume. Then one last one, circles. And circles, circumference and area. So the shapes I expect you to know. Triangles, which would then be Pythagorean theorem, area, trigonometry. Squares, area, perimeter. Boxes, surface area, volume. And circles, circumference and area. Those I expect you to know. Other shapes, like a cone, you're just going to look those up for homework. Okay, so we're up to this point here. If you can get to this point, virtually all the steps after this on every single problem are essentially the same, a little bit different for the different numbers in each one. But here's the setup, and if you can get through the setup, you can usually finish the problem. And so step 5 here, implicitly differentiate with respect to t. No, that's not quite the next step here. So I'm going to white this out. That's almost the next step, but not quite what I want to do. So we'll forget that this happened, and I'll just white it out. And we're at 12 minutes, so I'm going to conclude this video, and we'll finish this problem up in the next video.